This is a parabola, and I am asked to find, well, I don't know what I'm asked to find. Let me look. It wants the vertex, the focus, the directrix, the endpoints of the latus rectum. Again, here's, well, not again. I just made a video on the features of this, so I'm saying again, but not in this video, it's not again. Here's the focus, here's the vertex, here's the directrix. This distance, and this, the distance from the vertex to the focus and the vertex to the directrix, those are equal. What else does it want? It wants the vertex, focus, directrix, include the endpoints of the latus rectum in your sketch. So it wants to know, here's a latus rectum, that's the distance or the diameter of the vertex in a line that is parallel to the directrix and across the focus, and that equals 4p. So I can find, once I know the point of the focus, I can just go 2p to the left. That is 1 point on the end of the latus rectum. 2p to the right, that's another point on the end of the latus rectum. Latus rectum means straight side. Latus means side, rectum means right. In this context, that means straight. So this is the vertex form of the equation. This one is x minus h squared. See, the x term is squared equals negative 16y. I know that the general form, oh, it's x minus 3. I was writing the general form. The general form is x minus h squared equals 4p times y minus k squared, where hk is the vertex. So nothing is added or subtracted from y. It's minus 3, so minus 8, so I have to change the sign. The vertex is at 3, 0. That's the vertex of this parabola. Now I will graph this in a moment, and I'll show the graph on Desmos just to show that I got it right. Now this term is negative, which means this is going to be an upside down parabola. It's going to look like that. If that number is positive, then it would be an, if this number is positive, then it would be a right side up parabola. It would open like, excuse me, that. So vertex, man, I keep forgetting what I'm supposed to find. The focus. How do I find the focus of this thing? Well, 4p equals negative 16, which means p equals negative 4. Negative 16 divided by 4. The focus, and again, this is an upside down parabola, is going to be p away from the vertex. So this is p. And that shows it's indeed an upside down parabola. So the focus, notice this is a point hk. The focus is going to be the same h value, it's the same x value, but I'm going to add p to k. So this is going to be 3, same x value, and then 0 minus 4, which is minus 4. That's the focus of this parabola. Now it wants the directrix. So I need the directrix. The directrix is a line. And the directrix is the vertex. In this case, it's going to be h, k, minus p. It goes the opposite direction. It's the same distance from the vertex that the focus is, but in the opposite direction. So this is a vertical parabola. So this is directrix. Directrix is going to be a line. In a vertical parabola, it's going to be y equal. And it's going to be some number that is opposite the direction from the focus. So the focus is at 3, negative 4. This is going to be minus 0 minus negative 4 is 4. So it's going to be y equal 4 is going to be the directrix of this. And then it wants the, endpoints of the latus rectum. Well, if the vertex is at, focus is at 3, negative 4, here's 3, negative 4. The latus rectum is going to be 2p to either side of that, because the whole length of that latus rectum is 4p. So I've got 3 minus 4. Now this is going to, in a vertical parabola, it's going to add or subtract to the h, or not to the h, to the x component of the focus. So this is the Latus rectum endpoints. I'll just put LREP. So focus is 3, -4. If P is -4, 2P is -8. So I've got 2P equals -8. So it's going to be 2 plus 8, 2 minus 2 plus -8, 2 minus -8, which is 2 minus 8 and 2 plus 8, 3. The focus is at 3, not 2. 3 plus 8 and 3 minus 8. So 3 minus 8 is -5, -4. And then 3 minus -8, which is 3 plus 8, is 11, -4. So that's all the features of this thing. And now I want to draw it. So what will I do here? I'm going to copy this and move it down so I have some room next to it so I can draw the parabola. There. Okay, so here's my coordinate plane. I got the vertex is at 3, 0. 1, 2, 3. That's the vertex of this parabola. The focus is at 3 minus 4. 2, 3, 4. 3 minus 4 is the focus. The directrix is at y equals 4. 1, 2, 3, 4. That's the directrix. The endpoints of the latus rectum are -5, -4. -1, 2, 3, 4, 5. -5. Whoops, I didn't draw that in the right spot. This one has to actually go down a little. -5, -4, and 11. 3, 4, 5, 6, 7, 8, 9, 10, 11. And 11, -4. And now I can kind of draw this thing. I got to get it through the vertex and through those two endpoints. So that's pretty good drawing of it. And actually, I've got to show the parabola as the only solid line of this. This is y equals 4 is the directrix. So there's my parabola. And now I could make it even a little more accurate if I can find the y-intercept. See, because this one, it only touches the x at the vertex. But what about the y-intercept? Where does it touch the y? Well, let me make the x 0. So I have x 0 minus 3 squared equals -16y. That's minus 3. Minus 3 squared is 9 equals -16y. And then I got -9/16, which is, let's see, 4 times 2 is 8. 2.25 over 4. Boy, it's close to 1/2. Let me do it on Desmos, just so I can get it exact here. Maybe without a calculator, you'd say, well, 1/2 is good enough. But I'm going to do -9/16. It is kind of close, -0.56. So this should be, -0.56. Yeah, that's pretty good, I think. Because there would be, my drawing isn't bad. I got it. Okay. So that's it. Those are the endpoints. And you would label these. This is -5, -4. Let me see what it said again in regard to labeling. We got to get all this right. It says find the tangent, include the endpoints in your sketch. Yeah, so I think it wants me to label all of this. This is 11 -4. This is the focus, which is 3 -4. I'll put the focus. This is the vertex, which is 3, 0. And this is the directrix, which is the line y equals 4. And I think that would be good enough for a sketch of this parabola.